When I was at school, evolution was taught in biology lessons, according, I suppose, to the UK's prevailing national curriculum. We had two main biology teachers, Mr. Davidson, a remarkable ex-soldier with a passion for discipline, and Mr. Toogood, whose enthusiasm for his subject seemingly knew no bounds. Between them, they variously terrified and inspired generations of kids at Workington Grammar School into getting the basics of evolution by natural selection, along with other things. But knowing what I know now, I have to say that the curriculum, presumably through no fault of Mrs. Davidson and Toogood, was sadly lacking. You see, it missed out the most important part, the key bit of natural selection that makes sense of the rest. They missed out equilibrium. Mrs. Davidson and Toogood taught us all about evolutionary change and how survival pressures favour certain genes leading to adaptation, but they neglected to inform us that natural selection usually favours no change at all. They didn't explain that speciation isn't the norm, it's the exception. That's why chromosomal changes that lead to issues like Down syndrome don't take over the planet. These are real genetic changes, but they hold no advantages in a relatively stable environment, and so they don't prevail. Natural selection usually favours what has gone before, because what's gone before is usually already well adapted to its environment. My parents lived long enough to breed. That means natural selection has no reason, all things being equal, to make any great changes to that basic genetic structure because it worked. Evolution hasn't stopped, as we shall see, but that doesn't mean that it has to impose change for change's sake. As the maxim goes, if it ain't broke, don't fix it. This is why Stephen Jay Gould came up with the term punctuated equilibrium, to explain the pattern of prolonged periods without change, occasionally punctuated by rapid explosions of adaptation and speciation. Some commentators have dismissed the concept of punctuated equilibrium as flawed, because it doesn't quite meet the criteria of gradual change over time. Also, Gould used it to try to explore some of the gaps in the fossil record, which caused a few problems in itself. But really, it's a logical conclusion of a system of natural selection that responds to change, but maintains stability in periods of constancy. It's only when the environment or other circumstances change that natural selection starts to favour adaptation. In a stable ecosystem with no significant pressure to adapt, very little changes. That's why certain apex predators, such as sharks or big cats, seem not to have changed particularly for thousands, if not millions of years. There's no need for them to change. They're successful as they are. If all the fish suddenly died out, then sharks would need to adapt. Natural selection would begin to favour those sharks who, by some genetic fluke, had developed the ability to digest the hulls of wooden boats. They'd survive, whilst their followers, with less digestive options, would die off. Eventually, all sharks would be adapted to eat wooden hulls, and small fishermen would have a bit of a problem. This change in diet caused by the death of a food species is what we call a selection pressure. One of the basic problems that people have with evolutionary psychology is they don't really understand selection pressure and the role that it plays in making change over time. Nor do they understand that whilst physical traits can change and evolve because of our genetics, psychological, mental changes happen too. As this series progresses, I hope to make this much clearer. Evolutionary psychologists used to work to a one gene, one trait model, where it would have been possible to find a single gene to explain a single trait in humans. In fact, that isn't the case. Rather, there's a complex interaction between genes and their environments that shape our experience. That's what we mean by the modern Darwinian synthesis. The role of natural selection in favouring some genes and not others has stacked the deck, but the environment still plays a part. It's not nature or nurture, it's nature and nurture combined. Traits are selected because they're helpful in certain circumstances, although they may not be helpful in all circumstances. So responsiveness to environment plays a role in human psychology. A good example of this comes from the realms of physical advantage and disadvantage via natural selection. The genetic defense for malaria also creates sickle cell anemia. Therefore, in areas of the world where death by malaria is commonplace, sickle cell anemia is also commonplace. There's an evolutionary trade-off. In areas of the world where malaria is rare or effectively unheard of, sickle cell anemia is also rare or unheard of. Other examples of this trade-off with regard to physical traits involve the male peacock's tail feathers, which, although increasing breeding opportunities, makes him more visible to predators. The same trade-off was observed in the Trinidadian guppy populations I mentioned in an earlier video. Evolutionary adaptations, be they physical or psychological, tend to be much more complicated than mere either or equations. I'm Stuart Sorensen, and this is Mind the Care training. If you found this video useful or helpful in any way, please feel free to share it around and click the like button. Oh yes, and while you're at it, if you click on the little character icon that's on your screen right now, you can subscribe to the channel and you won't miss any other videos. Thank you for watching.